Okay, let's get started. Uh, just a moment, first of all. Okay, everybody, can you see my screen?
Yes, we can.
Yes.
Yeah, so you know the final exam information for you. You will take the final exam on November 24th. This means coming Tuesday. Uh, this is the university allocated time 10:30 a.m. to 12:30 p.m. But then as usual, I will allow you 1 more hour, so you can start at 9:30. So the final exam will be available on eCourseware at 9:30, and then you can start at 9:30, and then deadline to upload on Dropbox at 12:30. So likewise, midterm exam, again, you are getting 3 hours. But here I have mentioned just this is the university allocated time. And then in terms of syllabus, you have to look everything, follow all class lecture, numerical problems, homework, class quiz, conceptual questions that we discussed. If you look the book, so these are the chapters 2, 4, 6, 7, 8, 9, and 10. And then question pattern will be the same as the midterm exam. I mean, the similar thing. And then also, please don't forget to complete setting. So I believe there is a deadline, and then I recommend you all to do that. And then soon this week, you will know your grade for the midterm exam 3, and then second class quiz. And also, I think the 2 homework grade is pending. So everything you can know very soon. I mean, in a day or two, I will notify you. So is this fine? Does anybody have any question?
Sounds good to me.
Okay, I will give you a reminder again so that you don't forget. Yeah, just keep in mind November 24th. This is coming Tuesday. Okay, so with that, now let's get started your class project presentation. So first, I'd like to invite Omar and Jared. The title is Electric Machines Used to Treat Patients in Hospitals. So please, Omar and Jared, keep going.
All right. I'd like to apologize in advance. I'm in a coffee shop and there might be some music in the background. So,
Okay.
that being said, I'll go ahead and get started. So, my name is Jared Joyner and I did my project with Omar Sakar. We did electrical machines used to treat patients in hospitals. There's a lot of various applications for electrical machines in hospitals, from motors to transformers and everything in between. So, yeah, without further ado, we'll get started. And Omar's going to talk about electric ventilators.
How y'all doing today? Everybody can hear me good?
Yes, I can hear you.
All right, I'll start off with electric ventilators. Electric ventilators are basically devices that will assist you breathe if you're having a hard time breathing. These can help your lung muscles work a lot less. I put in a lot less work. Here's some usability and benefits on there. Medical ventilators are a critical piece of medical equipment that quite literally save lives every day, especially during these hard times in pandemic due to COVID-19, since COVID-19 attacks your lungs and makes it very hard to breathe. We had a shortage actually on ventilators in the United States and all around the world because of all the patients and the need. So these are very important equipment. These machines serve to provide respiratory support for patients in distress who are suffering from immediate difficulty breathing on their own. A medical ventilator augments or replaces the work normally done by the patient's muscle to perform the work associated with respiration, the inhalation or exhalation of gases to and from the lungs. Medical ventilators are used to support patients both over the short term while recovering from illness or over long term due to chronic health conditions. Here's a control system diagram and functionality. There's a lot of different ventilators depending on the company and the manufacturer, but here's the basic works of it. The air enters the inlet filter appearing on the right side, right here of the diagram. Inlet filters are either consumable or replaceable, so they're placed in the mouth, so they either throw them away or wash them. As with previous design, this is an oxygen port or port for the supply O2, which is then mixed with the incoming air in the accumulator unit before being fed to an onboard rotary compressor unit that boosts the pressure of the gas stream to suitable levels. The pressurized gas mixture is then passed through a silencer to muffle the compressor, very loud noise, before being directed to the flow valve and passed to the inhalation tube of the ventilator. Powering the medical equipment uses 120 volts AC. There's, of course, converters in there, AC to DC and DC to DC, since some DC equipment like sensors, some use 12 volts, some use 7 volts, some use 5 volts. So we have to make sure the voltages of everything is working correctly. Usually compressors use induction motors, usually squirrel cage for compressors, since they're a little bit less maintenance required and a little bit more silent than other motors. Second machine we're going to be talking about is hemodialysis machines. Whether you do home hemodialysis or in-center hemodialysis, you'll rely on hemodialysis machines to filter your blood. The machine filters your blood through a dialyzer, also known as an artificial kidney, with built-in safety checks to be sure to the process is safe and effective just in case of power outage, pH levels are off balance, or anything that not working accordingly. Here's some components of the machine. The main components that we have is a deaeration, dialysate, proportioning and conductivity, dialysate formulation, monitors, alarms, and conductivity. Ultrafiltration has volumetric and flow sensor control, dialysate disinfection and rinsing, so make sure it's sanitized, and emergency stops and alarms. Our third machine is the defibrillator. This is a very old machine. I will give a little bit about the history about it. The discovery that is misfiring of the heart could be started using an electric charge is one of the greatest development of modern medicine. This idea has begun around 1888 when it was suggested by Mac William that ventricular fibrillation might be the cause of sudden death. This happens usually when they're doing surgery and patients get a heart attack or some blood clot, or it attacks basically their heart, and they need some electric shock to get the heart pumping again. Here's some application of it. It's used to treatment of ventricular fibrillation, is an example of an instrument in which electric charge is stored and then released in a controlled fashion. The key component of storing the charge is a capacitor, which consists of two plates separated by an insulator. Defibrillators are set according to the amount of energy stored, and this depends on both charge and the potential. This can be shown as follows, and here's some formulas that show the voltage, the power, the current, and the stored energy is multiplied by 1/2 of the charge and potential when it's outputting to the patient. The last machine we're going to be talking about is oxygen concentration machines. These machines are very important for people who've smoked for a very long time, have heart disease or lung disease where they have a very hard time getting oxygen, pure oxygen. My dad actually used to use one of these. He smoked for a very long time and it's not fun. So this helped a lot for him to breathe. Here's a oxygen concentration machine functional decomp diagram. So it just takes air from the outside and it sucks it in through a compressor. It is filtered with from the debris that's in the air first, and then inside the compressor there's two plates of zeolite beds, and these catch nitrogen atoms and make all the gases a lot easier to pressurize, and basically it's a lot easier to take the oxygen out of the water through the nitrogen flow. And then we have a flow meter also, which allows us to control how much output of oxygen the patient would need, and then that will be delivered to the patient through a tube. And they have also masks if you don't want to use a nose tube. Here are some components of the machine if it was taken apart. We have an intake filter, oil-free air compressor, intake noise filter, a shock absorber, oxygen cylinder, a valve, dinitrogen filter, a sieve bed, a PC board, pressure sensor, oxygen purity sensor, bacterial filter, and flow meter. Motors used in the oxygen concentration machines. Induction motors are mostly used in compressors all around, not just for oxygen machines. As a prime mover, the motor needs to supply sufficient power to start the compressor, accelerate it to full speed, and keep the unit operating under various design conditions. Most air compressors use a standard three-phase squirrel cage induction motor, which we learned about in class. And the ones used for the oxygen machines usually output around 100 watts of power. And Jared will take on from here.
The next thing we're going to talk about is electrical surgical drills. These have various applications in the medical field, also in the dental field, from drilling teeth to drilling holes in bones to various surgeries. So, if you could go to the next slide. Okay. So one of the first purposes they have is craniotomy. So this is like the removal of the ovular part of the skull to access the brain for brain surgery. And as you can imagine, that this has to be very precise and done very carefully. So the motor, it needs to be easily controlled with minimal vibration. And that's a key thing to these surgical drills, is easily controlled with minimal vibration. So the next thing that they're used for is to facilitate spinal decompression and instrumentation. And what that is for example, you have a slip disc in your spine. The surgical drill is going to go in, it's going to remove the excess cartilage or anything that needs to be taken out, and that would be the decompression. And the instrumentation is for adding either synthetic cartilage or a support, and you have to drill holes for screws for supports and things like that. And once again, it needs to be very easily controlled with minimal vibration. So the next thing that they're used for is drilling holes for bone screws in orthopedic surgery. So this is, drilling holes if you want to replace a hip or a knee. You have something to fasten that to. And they're used to drill the holes to actually put the screws to mount the prosthetics or synthetic bones. So that's what they're used for. Now we're going to talk about the kinds of motors that these things need. And they're usually brushless DC motors because of how easily they're controlled, like I said, and they have minimal vibration. They also have some great efficiency of the different types of motors, which is very important when it comes to performing operations and surgeries. Like the smallest slip, the smallest mistake can cause something drastic and very malevolent to happen. So in order to avoid that, they go with brushless DC motors. That also makes the device easier to sterilize just because of the structure of the device. There's not a lot of like enclosed parts. It's easy to get to everything that needs to be clean. Because it's basically an inside-out version of the brush DC motor. And it being brushless also extends the life and minimizes maintenance of the system, which is very important because of how expensive these tools are, considering that they have to be, medical grade. The housing is a very expensive material, and it's just best that these things don't have to be maintained over long periods of time. And it does have significantly less vibration than other motors, so that adds to the machine being easily not just easily controlled in terms of speed and but easily controlled in terms of like holding the actual device and being able to control what you're doing with it. So that's it for surgical drills. The next thing we're going to talk about is medical pumps. And this is a very generic term. There's many different kinds of medical pumps, but we're only going to focus on 3 of them for the sake of time. The first is an infusion pump, and this is used to deliver um, nutrients or medication to a patient, and they're often specialized. If you can go to the next slide, please. They're often specialized for different areas of the body. Some of them are, honed in just on the digestive tract. Some of them focus on the bloodstream. It's often used for pain medication, or if a patient can't eat, they have to get nutrients some other way. So that's what the infusion pump is used for. They can either be, done in small amounts or large amounts, and stationary or mobile. So this means like either in center, like you're in the hospital, or you have to take it home with you and use it at home. The next type is a compression pump. So these are used when a patient has to undergo a compression therapy. So this is basically the same principle as like a blood pressure gauge, where you have a thing that wraps around your arm and it inflates. It's the same concept, except it is specified for a specific part of the body. For example, a lymphedema compression pump is about the size of like a normal leg. It goes around your entire leg, and it treats the swelling caused by lymphedema, which is the poor circulation of the lymphatic system, causing large swelling in the legs. And this just wraps around your entire leg, and it just fills up this bag of air and compresses your leg in order to improve circulation. It's a little bit counterintuitive, but it's how it works. Another type of compression pump is a DVT compression pump, which is very similar to the lymphedema compression pump, but what it's treating is different. It's treating blood clots to improve blood flow. And this can be done in various parts of the body, not just the legs, but it is usually the extremities like arms and legs. But it is overall very similar to the lymphedema compression pump. And the third type is a vacuum pump, and this is generally used for air quality control in hospital rooms and surgical rooms, which is very important. They have to be very sanitary. They have to meet NFPA 99 codes. Lots of times they're air cooled with no water, and they need to be very quiet so as not to disturb the patients or anybody in there. And now we'll talk about what kind of motors are used in these pumps. So there's various types of motors used for these pumps depending on what the pump is doing. So what they often use, not so much now, but it's kind of going away from this. But most of the time they use ironless brushed DC motors in battery-powered pump operation. So if you have to use an infusion pump at your house or something like that, you're going to use ironless brushed DC motor in your pump. This is iron loss as opposed to iron brushed DC motor, but it is pretty dependent on the bearings. So now they're going more towards brushless DC motors for these pumps, as many things are in many applications of motors just across all fields. Brushless DC motor seems to take over the market there. They have no iron loss, and they also have reduced dependency on the bearings, and it just greatly increases the life and reliability of the motor, not to mention it reduces vibration and noise, and it's just a much more sound choice for a motor. But when control is priority, then they'll take it to the next level and use a stepper motor, which is just a specific type of brushless DC motor. They can't operate at high speeds, but they're extremely efficient and controlled. They're mainly used in battery-powered infusion pumps, but they can also be used in many other applications across the medical field. So that's it for motors used in medical pumps. These are our references.
Any questions, comments, concerns?
Okay, thanks so much, Jared, for your nice presentation. So is there questions, comments for them?
No questions, but good job, guys, and good job, Jarrett, for being in the middle of a coffee shop.
Thanks, man.
Any other questions, comments for them?
No, that was a great presentation. Good job, guys.
Yeah, it was quite informative. Okay. Okay, thanks, Jared and Omar again. Then please upload your presentation.
Yes, sir. Thank you.
Okay. Okay, so I think the next one is monitoring smart energy meter data on smart television screen by Samuel, Patrick, and David. So please go ahead.
All right, good morning, everybody. Thank you, Dr. Ali. Thank you, Jared and Omar. Very nice presentation. So, like Dr. Ali said, me, Patrick, and David worked together in a group. And our project is a little bit different from everybody else's because we're all computer engineers. So we had a data analytics component to our project. And so we had a good time with it. I think we learned a lot and we enjoyed the process. So I'm going to give you an overview of the project. And if we can get to the outline, I'll tell you the overview of our presentation. Great. Cool. All right, so I'm going to give you the introduction and the overview of Splunk, which is the tool we've chosen to use. David's going to go over the MLG&W smart meter data. He's also going to talk about a dashboard he built to show average hourly usage. Patrick is going to show us monthly power costs, and I'm going to talk about temperature trends, and then Patrick is going to talk about displaying these dashboards on a smart TV, and then I'm going to wrap this up. So when we started the project, I sent an email to Phil Fentress, who's a substation engineer at MLG&W, about data requests. And so he gave us some information about their data requests and told us that we're able to export a CSV from our MLG&W account that has 2 years of historical data. So we exported that, and then David actually compiled those CSVs into a single CSV, and then we imported them into Splunk. Now, Splunk is a data analytics tool. So it captures, indexes, and correlates real-time data in a searchable repository from which it can generate graphs, reports, alerts, dashboards, and visualizations. One thing that's cool about Splunk is that it's used by 92 of the Fortune 100. So this includes Disney, Coca-Cola. Disney actually uses Splunk to keep track of their roller coasters. So any data that comes from a roller coaster starting or stopping, you know, all the way down to brake stopping distance or when an emergency stop occurs is all logged into Splunk. And Coca-Cola uses Splunk for their Freestyle suite of products. So when you go to a restaurant that has a Coke Freestyle, it's sending data in real time about its inventory and other data, and so they can monitor that remotely from dashboards. So we chose to use this tool because of its power and its popularity. And so what we're doing is hosting this instance of Splunk Enterprise. This is a free trial that we're using on a Microsoft Azure machine that Patrick set up. So for anybody who's not familiar with that, it is a remote Linux server. And so we're hosting it on that, and you can even see the IP address up top. And so that's how we've set it up. And what I'm going to do now is have us go to the search screen, and then I'm going to show you the raw data, and then I'm going to turn it over to David to talk about what data MLG&W provides. Cool. So this is an overview of the Splunk screen, the search screen. So you see he just typed in our host, which is Energy Conversion Project. We have some other sample data that we popped in here just to test the software. And so he specifies that he chooses all time because we want to get all of the data available. And then what you see here is each row in this table is what they call an event. And so I'm going to actually turn it over to David, and he's going to tell us about the data that MLG&W provides to us.
All right, so when you go onto your account in MLG&W, you can download about 2 months worth of power usage data. Each is time-stamped, with a date, and each event is about in 30-minute increments, so each day has about 48 entries. And with all those entries, there is the amount of power used during that increment. As I said, the data is in 2 months increments, so I had to compile about 2 years worth of data that Sam provided. You could, if you could get somehow give the credentials to Splunk, you could theoretically take an input and just have it every 2 months, go in, grab the new data, and append it to the end of the currently used data. Moving on, you can go to my dashboard. All right, so using Splunk, you can make what's known as a dashboard, and you can make a whole bunch of charts and graphs. I've chosen to make seasonal hourly average usage graph, which gets the average per hour during the season of how much power is used. Over a 24-hour period, you can see that the trends stay mostly the same, where from about midnight to 11 a.m., power usage is small or relatively low, with a small bump at around 6 or 7 a.m., which is around when people start getting up, turning on lights, and using appliances. And then just around 4, you see that the graphs normally spike around there. That correlates to people getting home, starting to turn on the lights, using appliances. As you can see, in the summer, the power usage is much higher than any of the other seasons, and I believe that's mostly due to HVAC system. The cooling and condenser system uses a lot of power. While in the fall, I believe this person has a gas HVAC system, so it doesn't use as much power as an electric one would. With that, that's all my dashboard shows. Patrick, I don't think we can hear you.
Sorry, mic was muted. I've been working on showing how much you use in a year or every month, but I showed how much was used in 2019 and how much was used in 2020. And by comparing the two, you'll be able to see that Sam's house has used a lot less electricity in this year. It's not complete because we're not in 2021 yet, but it's already showing a good reduction. On the right, you can kind of see how much this is costing each month. But this shows the 2 years that David was able to compile. MLGNW has started giving a time of use option for smart meters, whereas if you're using less power during peak hours, you'll get a price reduction, or if you're using more power during off-peak hours, you'll also get another reduction. What I tried to do at the bottom here is show how much you could save in comparison by using this time of use option for 2019. Here we see in August they spent around $300. If I can find it again. In August they spent around 174, or they would have. But I'm going to talk briefly about how you would set this up. You would have to make sure it selects winter. Then it would go through, find the correct weekdays and peak times, and then calculate it. Then find summer, so on and so forth. But whoops. I'll take you to see Sam's temperature data.
Okay. Hey, Patrick, if you don't mind, do you think you could go back? I think if you'd want to,
Oh,
maybe show some of the queries that you worked together.
yes. Sorry. Oh, this is sort of what the time of use option would look like. It's not very pretty, but you can also operate in using the source code, and it's also not very pretty, but it lets you have greater control over all the UI and how things look. And if you wanted to, you could add images, text, all of that. That's how I managed to get this short paragraph. And later I'll show a video of the TV setup with this link.
Very good. Thank you, Patrick. So I'm going to talk about now is temperature trends. So when Patrick opened up the query that generated his dashboard panels, that's called the Splunk search processing language. And it just allows you to generate the graphs like he's done with his panels. And I would say very nice job, Patrick, because none of us had really used Splunk too much, and he really took it and ran with it. And I think we've all learned as a result. So what you see on your screen now is some temperature trends. And what I wanted to do was find some data for the Memphis area that correlated to the same time frame and import it and graph it on the same axis. But I had a hard time doing that. So instead what I settled for is finding an image of the average monthly temperature trends. And so like David had mentioned, this data is from my parents' house, and they do have a gas heater. So during the winter months, the electricity portion of the bill does decrease. And you can see that as, like let's take August, for example. Uh, Patrick, if you could hover over maybe one of the peaks on the graph, and we can see what the total kilowatt hour usage is for that month. And then you can look at the graph and see how it correlates to generally the temperature increases and the bill increases as well, because we want to stay cool inside on the hot days. And I think that's all I have here.
Okay, I'll start talking about how to set up the smart TV. You would have to, for a, say one you would have on the same Wi-Fi as this computer, you would just need this Splunk secure gateway, which you can download from this Find More apps part and the smart TV app. But for say a TV that you don't have at your house, you would have to actually physically download something onto this virtual machine called the Secure Cloud Gateway. But I'll talk more about that later. But after you download it, you'd have to give the gateway permission to operate and connect to the TV. First, you'd have to come here and tell it can write stuff and send stuff. Then you would have to enable it. But once that's all set up, you can just go to this Splunk Secure Gateway. And once you download the Splunk app on your TV, it'll give you a code for activation. And then once it sets up, you should receive a code to ensure that it's connected successfully. But I will now, as you can see, that's the app for the Splunk you can move over to the dashboards, and that's let you connect to various other ones. You can see the Splunk Secure Gateway. I should have showed that, but it can let you check the data on your connection. As you can see, I'm going over David's seasonal usage. And if you want, you can zoom in and you can get a closer look. There's a slight problem with my TV that it didn't want to fit it correctly, or it wasn't the correct bounds. You can see my monthly usage and monthly costs. I'll scroll down in a second and show you the time of use. But this can be set up on a variety of smart TVs and smart TV connections like Apple TV and Fire Stick, the Amazon Fire Stick. But that's it for. If I'll show you in a second the secure gateway just to show you this is just to let you know that everything's connected all right and let you check the connection. Pass you off to Sam for the conclusion.
All right, thank you very much, Patrick and David. So as you can tell, we wrote some code for this project. We pulled in the data to Splunk, and then we've shown it to you on 3 different dashboard panels, and even gone as far as showing how the dashboards can be actually shown on a smart TV, such as an Apple TV like he's done. Splunk also has mobile apps. I think the Splunk mobile app was released within the past few years because I remember at some point in 2018, they did not have it available. So having it on a mobile app is super cool, as well as on the TV, because I mean, just imagine walking through whatever site you're wanting to monitor and having your dashboard easily on a TV. So I would say that we've really enjoyed this project, and thank you for your time.
Okay, thanks, Patrick and David, so for your nice presentation and demonstration on the data ability on the smart TV screen. So, like as you mentioned, I think it can be equally displayed on a smartphone, right? A smartphone or a smartwatch.
That's correct.
Okay, that's great. And although you took data from MLGW, but can you not display your own smart meter data? Like you have an MLGW account, right? So if you can have access your own MLGW account, and I think that data can be displayed as well.
Yes, sir. This is the data from my house that we exported from my account.
Oh, it is from your house. Okay.
Yes, sir.
Oh, so then what data did you take from MLGW?
Well, we didn't take any data outside of my account.
Ah, okay, I see. And then the temperature data that you showed, that is for Memphis City. You took it from just one line, or that is
Yes,
also
sir, from
available?
online. The source rssweather.com.
Ah, okay, from there. Okay, so that's great. So does anybody have any questions, comment for this group?
No, I think they did an excellent job.
Yeah, this is great. Okay, so thanks, Sam, Patrick, and David once again, and please upload your presentation on Dropbox. Okay, so for today, the last presentation is a development of simulation model of induction generator considering variable terminal capacitor And the presenters are Alexandria, Muna, and Mesa. So please go ahead.
So our project is a simulation model of induction generators considering a variable capacitor by Alex Golden, Raina Mohammed, and Robert Massa. In today's presentation, we're going to give a background on induction generators. We're going to talk about the impact of capacitors on induction generators and how that leads into them being self-excited generators, as well as how we went about doing this. We're going to also show our circuit design and our simulation results. Then we're going to talk about what it all means. Muna, can you go to the next slide? Or is it not updating for me?
Yeah, it's not updating for me either.
So an induction generator is often referred to as an asynchronous machine. It's an AC machine that relies on induction to provide electrical power. Induction generators produce electrical power when the rotor turns faster than synchronous speed. These are widely used in many hydropower plants and wind turbines because of their low cost, low maintenance, variable speed, and high energy capture efficiency, as well as their improved power quality. Induction generators tend to rely on excitation power from an electrical grid, but today we're going to talk about how they can be self-excited with the use of phase correcting capacitors.
So it's not moving. Hello, Mesa, could you hear me? Yeah.
Okay, can you see it now?
Yeah, I can see it.
Okay, I don't know why it's not moving every time. I'm trying to, sorry about that. Here we go. All right, sorry. I'm gonna discuss the impact of capacitors and induction generator. I'll start with discussing what a capacitor is. An induction generator, well, a capacitor is an electronic component that stores electrical charge similar to a battery. It is able to store a substantial amount of energy, and a properly designed bank of capacitors can return the energy in a very short burst at a very high power. These powers can be so high that the output can exceed the output of a major generating facility, such as like one that supplies the city. Relating to a system, a generator, such as a generator, the capacitor induces voltage into the rotor as well as regulating the voltage. If the generator is a brush design DC generator, it fills the gap between disconnecting amateur and then north and south poles traveling until the time it reaches to the south and north travel. And the amateur reconnects with the brushes in reverse polarity to make sure the DC stays constant. If it's an AC generator similar to what we're using right now for our project, it aids in keeping the phasing corrected for perfect sine waves and can cancel any stray inductive impacts. If you increase the capacitance above the required limit, which is like something that we don't want to do, it will increase the current in the starting winding. We don't really want this to happen because it will increase the heating and reduce the efficiency and the life of the system. In a self-excited system, the function of a capacitor is connected across the stator terminals, and it helps provide the required reactive power to fulfill the needs of the generator and the load. For maintenance purposes, for a capacitor, we want to make sure that it's not connected without a load. If a capacitor is connected only without a resistive load included, it will damage the capacitor as well as like blowing off a fuse and messing up the entire system. Most times, whenever you're troubleshooting generator, if you notice an electrical issue, you might want to check the capacitor. So you'll just turn off all the system, make sure everything is out, and just disconnect the capacitor, discharge it, and troubleshoot it on its own to make sure that it's acting properly. And then once it's connected, make sure it's fine. So you want to make sure, like if the generator is not exciting on its own, if it's a self-excited generator, if it's not exciting, then you would know that it's the capacitor might be the issue, as well as if the voltage being displayed is not stable, then you can say the capacitor is faulty. All right, I'm going to move on to the, can you see the next slide?
Yeah, yes, I can see.
Okay, perfect now. Okay, for our assignment, we were asked to simulate a model using induction generator with a variable capacitor. We decided to work with a self-excited induction generator because it is possible to regulate the voltages by placing capacitors across the lines. The level of output power can be changed by changing the amount of power taken from the generator, and the level of excitation can be adjusted by installing the correct capacitor size. And if you add another capacitor in parallel to it, you can pretty much move the capacitor up and down, as Alex will talk about later. So pretty much a self-excited generator is an induction machine that requires active power for excitation. Connecting a capacitor breaks across the stator terminal supplies reactive power to the machine and the load. When the rotor is rotated at enough speed, a small voltage is generated across the stator terminal due to the residual magnetism. And due to the small generated voltage, capacitor current is produced, which provides further reactive power for magnetization. All right. A self-excited induction generator is good candidate for a standalone operation. Pretty much an induction generator is essential because it needs lagging current to magnetize the core. It draws reactive power from the grid, and the reactive power drawn by the induction generator has to be compensated by the capacitor. So for us, like we kind of wanted to create like a similar, like a standalone operation system, similar to like what Rob might discussed about like, you know, wind turbines and stuff. So this is a good system for that. It's also economically more attractive, it's cheap, doesn't have a lot of maintenancing issues, and the size of the capacitor affects the level of excitation that's the available voltage generated, and that's what we wanted to do for our project. Some of the advantages is like it's rugged, it's inexpensive, and offers simplicity when connecting to electrical networks. And disadvantages of a self-excited induction generator is it requires reactive volt ammeters from the auxiliary equipment, and the volt ammeters are needed from the supply mains for excitation. I'm going to pass it on to Alex to talk about the rest of the information.
Okay, so just going over what's out there and then the advantages and disadvantages. So again, the self-excited induction generator has poor voltage regulation. This is what we proposed a solution for. The excitation control and voltage control is obtained by varying the net reactance. And there are various methods proposed to overcome this regulation disadvantage, such as VAR compensator or static VAR compensators. This consists of thyristor controlled reactors, switch capacitors, and harmonic filters. Or inductively loaded AC-DC converter. So to improve this voltage regulation. Although the VAR generator methods are reliable, they have prime disadvantages in their complexity and cost. The most desirable solution is to correct the regulation problem with the series variable capacitance, and this solution offers a more simplistic and inexpensive design while still providing reliability. So again, the proposed method for regulating the load voltage is a self-excited induction generator considering variable capacitors. This approach is going to utilize the design of a time-dependent switch to continuously control the additional capacitance. You can kind of see this in the overview of the block diagram. So the system is going to be composed of a fixed capacitor connected in series with a variable capacitor at each phase. The variable capacitor is modeled by connecting a breaker switch and a capacitor in parallel. Additionally, the total value of capacitance will be determined by controlling the switch's time input. The controlled time will determine the position of the switch and the length of time the auxiliary capacitance is connected. So when the switch is open, only the fixed capacitance is connected to the circuit, and when it's closed, the connection of the second capacitor will then be able to be considered. So this system is modeled off of the specifications, and we were also given certain parameters to input into the asynchronous machine. So we used MATLAB Simulink software to analyze and observe the signal measurements, considering the variable capacitor. So again, the asynchronous machine block is utilized to implement the three-phase induction generator, scroll cage type. A mechanical torque was needed to be inputted as a constant to the machine, and then it would have to be negative to ensure the machine acts as a generator. And then based on the specifications and parameters, the values can then be initialized in the asynchronous machine. The breaker switch varies the connection of the time of the additional capacitance. So that capacitance bank with the series variable capacitance is directly connected, as you can see, to the asynchronous machine. This breaker block is controlled through an internal timer and an additional control signal of 0 or 1. We initialized at 0, so it would be open at first. And then a three-phase purely resistive load is applied, and a three-phase AC source is connected. So here the line-to-line voltage is measured to observe the voltage regulation change once the series capacitance is connected and without the capacitance there. So we actually did not meet the requirements of the voltage regulation, and this design will need further improvement as far as parameter calculations and ensuring that all the right parts are used in the simulation. And so the observed outputted signals, you can see that they do change by a small amount when the switch or the capacitance is added. It just spikes the voltage slightly after 5 seconds, 10 seconds, 15, and 20. So again, the position of the breaker switch is controlled by an internal timer. And so it starts at 0, and then you would input 5 first, and then it would close, and then you would go on in 5 second increments. And so this is the output. What would really be wanted is that the once the switch position has changed, you get better voltage regulation all the way through.
So our simulation design was an attempt to outline the process of modeling a self-excited induction generator with variable capacitance. The reason we, Mona, the screen stopped sharing.
I'll be right back. Sorry about that, I'm sharing right back.
So self-excited induction generators tend to have poor voltage regulation. So this design was intended to overcome this characteristic. The addition of variable capacitance allows us to enhance the performance of the voltage regulation at varying loads. The advantages are simple controls, low cost, and low maintenance. The proposed design we're working with right now is for a 1 megawatt, 690 volt, 1800 RPM, 60 hertz asynchronous machine. Our design did not meet the desired results, but with proper parameter calculation improvements, we could enhance the voltage regulation. Our design could have been improved more by using voltage sensors to implement a voltage dependent switch. That's all for our presentation. Any questions?
Okay, thanks, Masa, Alexandria, and Muna for your nice presentation. It's informative as well. Any questions and comments for this group? If no question, then thanks again. So you, Masa, Alexandria, and Muna. And any of you, please upload your presentation on Dropbox.
Okay, sorry about that. Mike, I'm using like a different computer today and it just like blocked me from doing anything for a moment.
Okay, no, that's fine. No problem. Yeah. Anyway, so today all presenter presented well on their projects. All are like nice presentation. So let's give them a big hand, all the presenters. Thanks once again. Okay, so once again, can you see my screen? No, I think.
No.
Oh, just a moment. Oh, no, I didn't click the share screen. Hold on. I think you can see now, right? That final exam information once again.
Yeah.
Yeah. So therefore, once again, those who have come late in the class, so please see, you will take the final exam on November 24th. And so regarding that time, as I already mentioned, you can start at 9:30. So therefore, you will get 3 hours. So you must upload by 12:30 p.m. Yeah. And then you have to look, this is comprehensive exam. So you have to look all class lectures, all numerical problems, summers, quizzes, those short theoretical questions. But the question pattern will be the same as the other midterm exams. Okay, so with that, today is the last class for this course, for this semester. Thank you all for taking this class. And I think some of you will be graduating, right? In December.
Oh, yeah.
Yeah, so that for those who will be graduating, so in advance, so congratulations on your graduation. And I wish you all the best in your life. And those who will be graduating like in spring or later, so anytime, so anybody, if you need any help for anything, any reference for your job applications or for anything, so please don't hesitate to contact me. So I can support your application by providing suitable references. So with that,